Hello everybody, the topic which I will be explaining you today in this video is the rate equations for four-level laser system. If you consider only four energy levels as 1, 2, 3 and 4 of an atom, a molecule or an ion, then we call that as our four-level system. And let us say that we have got a sample of these four-level systems with volume V, and if you count the number of these four-level atoms within this volume V of the sample, then if you get that some small n number, and if you divide that by the volume V, then you get the capital N, which we call the number density of these four-level systems. And within these smaller number of four-level systems, there could be actually some four-level systems with one electron sitting in the lowest level, that is level number 1, and other levels being empty. And if you count such systems, if you get their number as small n1, and if you divide that by the volume V of the sample, then you get something called capital N1, and this is called the population of level number 1. And in some other four-level systems, the electron could be only one electron could be sitting in the level number 2, and all other levels will be actually empty. And if you count such four-level systems, and if you get their number as n2, then if you divide that by the volume V of the sample, then you get capital N with capital N2, which we call as the number density of level number 2. And similarly, if electron is sitting in the third level and all other levels are empty for that four-level system, then if you count their number as a small n3, and if you divide that by the volume of the sample, then you get capital N3, which we call as population of level number 3. And similarly, for the case of top level, we can also define N4 as the population of level number 4. So if you actually define the energies of these levels as E1, E2, E3 and E4, and if you take the convention that E1 is less than E2 and that's less than E3 and that's less than E4, then by Boltzmann's distribution we'll be seeing N1 is more than N2 and that is more than N3 and that is more than N4, because the Boltzmann distribution says that as the energy of the system increases, then probability of finding electron in these will decrease. So anyways, the pumping scheme that I explained you for a four-level system is that initially when the electron is sitting in the level number 1, and when all other energy levels are actually empty, then we actually pump this four-level system with the help of some pumping photons, such that this electron is taken directly to level number 4, and from level number 4 the electron will relax to level number 3 very quickly, and level number 3 is actually a metastable state where the electron will live for a long time, relatively long time, and we achieve population inversion between level number 3 and level number 2, and because of that we start having the lasing action taking place, and from level number 2 the electron again will relax very fast to level number 1. So like this we start having the lasing action taking place between levels number 3 and level number 2. But as I said, naturally we have the population of N2 more than population of N3. That's because of the Boltzmann's distribution. But to achieve the lasing action between levels number 3 and 2, we need to have the reverse or inversion of this condition. So that's what is required for the amplification of photons that are coming because of stimulated emission between levels 3 and 2. So anyways, in the following we see uh, that when we can get this n3 minus n2 being greater than 0, we'll find mathematically the place or the conditions where we can achieve this n3 being more than n2. So anyways, for that we'll write something called rate equations, and rate equations will be written for n1, n2, capital N2, capital N3 and capital N4. So for the case of level number 4, we can write the rate equation as dn4 divided by dt is equals to, of course this n4 will change primarily because of absorption of pump photons. That's why we write this term W sub p, and it's proportional to n1. So if you have more 4-level systems as n1 kind of systems, then we can have more change of n4 happening. And we can also have loss because of stimulated emission of pump photons between levels number 4 and level number 1. So we can write W sub p, and it's proportional to n4 stimulated emission. And we can also have the loss of photons as 1 by T4, and it's proportional to n4. And over here 1 by T4 is taking care of all losses. That means decay of the electron from level number 4 to level number 3, or it could be from level number 4 to level number 2, or it could be from level number 4 to level number 1. In all possible, in both the possible ways, radiative and non-radiative decays. So 1 over 1 by T4 is equals to 1 by T4 3. So from this term is because of decay from level 4 to level 3, and it could be also involving decay from 4 to 2 and decay from 4 to 1. And as I said, 1 by T43 is again involving both radiative 43R and 1 by T43 and non-radiative. So this is because of spontaneous emission and also non-radiative decay process. Similarly, we can write even this 1 by T42 as 1 by T42 radiative and non-radiative as well, 42, and the last one also similarly, for 1 is equals to 1 over T for 1 radiative, 1 over T for 1 non-radiative. So anyways, this is just some conceptual information. We may not need this for our rest of the derivation much. So let me erase this and go to writing the rate equation for N3. So for the case of N3, we can write a rate equation as dN3 by dt is equals to, of course, this will change primarily because of absorption of the lasing photons. So we write something called W sub L, and it's proportional to N2. So if we have more N2s, then they will convert. as n3s in a bigger way. So we write this equation, and we can again have loss of lasing photons by stimulated emission of lasing photons between levels 3 and 2. So it's proportional to n3, and we can gain n3s from n4s by the conversion of decay from level 4 to 3, and it is proportional to n4. So we write this, and we can again have a decay of this as 1 by t3, and it's proportional to n3. So we write this t3 just the way we wrote t4. So even this 1 by t3 is again involving all the decays from level 3 to level 2, and from level 3 to level 1. And again this 1 by t32 is having both spontaneous emission 3 to r, and it's also having non-radiative decay process as well, right? So same story for even T31, having both non-radiative, spontaneous emission and non-radiative processes. This is 31 non-radiative. So anyways, as I said, these are only conceptual ideas, and we may not need them for the derivation that's coming in. So this was the rate equation for M3, and we can write a similar rate equation for even N2. That is dN2 by dt is equals to, over here we actually gain lasing photons. We gain N2s because of conversion of N3s into N2s by stimulated emission of radiation. So we write WL here, and it's proportional to N3, and we lose the lasing we lose N2s because of absorption of lasing photons. So we write W sub L here, and it's proportional to N2, and we gain N2s from the conversion of T4 to, from the process of decay of electron from level number 4 to level number 2. We have this term, and it's proportional to N4. And again we can have 1 by T3 2, and it's proportional to N3, and we can also have decay of this N2 by transition from level number 2 to level number 1. So this is T1 here, and it's proportional to N2. And this again 1 by Tn2, T21 is also involving both radiative and non-radiative. I'm going to use this term because it is only needed for conceptual purpose, but not for the mathematical derivation. So let us this one. And finally I can write even the rate equation for N1 as the dN1 by dt, and of course N1s will convert into N4s by the absorption of pump photons. So we can write WL, of course, with a minus sign, because this is a loss for N1. So this is wait a second, this is actually WP, because we are dealing with pump now. WP, and it's proportional to N1, and that they can gain because of stimulated emission of pump photons. So N4s will convert into N1s now, and it's proportional to WP, and it's N4 here. And we can actually gain from level number 4 to level number 1 transition involving non-additive and spontaneous. So it is N4 here, and we can also gain from the other things like 3 to 1 and N3, and we can also gain from 2 to 1 transition, which is proportional to N2. So we write this like this, and I forgot to actually label these equations. The first one I could actually call as equation number 1, and the second thing I think I can call as equation number 2. So this is equation, this is equation number 1, and this is equation number 2, and this is equation number 3, and this one is equation number 4. So if I call all these things, now what I do is I go to a place where we don't have any changing of these ends, I mean N1, N2 or N3s. So that state is actually called as a steady state, and at that steady state we can put mathematically, for example for N4 we can put dN4 by dt as 0. So from equation number 1, if you set the left hand stuff as 0, then if you actually in the last two terms take N4 as common factor out, then we'll be seeing W sub P plus 1 by T4 into N4 being equals to W sub P into N1. Okay, and from here we can actually invert. We can take T4 as a LCM here, and if you do so, then we can write T4 here, and we can put this bar for separation of numerator and denominator like this. And when we send this T4 guy as a cross multiplying to this one, and if this goes this side, then N4 will become WP into T4 divided by WP into T4 plus 1. So we get this expression for N4, and we may call this as equation number 5. And since I don't need this equation number 1 anymore, I might erase the equation number 1 and write this one over there, because we are lacking space here. So I'm gonna edit this one quickly, and in the place of that I will write this equation number 5, which is for N4. So N4 we are getting as WP into T4 all divided by WP into T4 plus 1 in a bracket, and we were calling this guy as equation number 5. So I may actually erase the rest of the stuff here, because I need space for further derivations. So now from equation number 4, what we do is when we put the steady state condition for this as dN1 by dt is equals to 0, we can set the left hand side as 0, and so this is coming from equation number 4. So 4 implies this one. And besides this steady state condition, we also take this T41 and T31 as infinity values. That means we don't have any decay happening between level number 4, I mean from level number 4 to level number 1, and from level number 3 to level number 1. So we don't have this. So because of that, when we put 1 by infinity, this term will become 0, and even this term will become 0. So what we have is just WP. Of course over here we can actually write minus sign outside, I think, and we can write WP also outside, and we can put N1 minus N4, that's this term and this term writing. This is 0, this is 0, and we have 1 by T21 and N2. So from here, if you send this guy towards this side, and if you send this guy toward this side, then we can write 1 by T21 into N2 is equals to WP into N1 minus N4. This is what we get. And in the place of N4, we can write the stuff from equation number 5. So if you write all the thing from equation number 5, then we get WP into T4 divided by, of course I forgot to write here that here we'll be having N1. So WP into T4 into N1 divided by WP into T4 plus 1, and now I can use a slightly different bracket like this, and I can even take N1 as a common factor out because it is there in both first and second terms. So if we do so, we can write 1 here, and we may not write anything here, but outside we can write N1 just adjacent to WP. And over here we can take LCM as WP into T4 plus 1, and if we do so, we'll write in the numerator of the first term we can as WP into T4 plus 1 and minus all this thing, and we can put this bar for both the terms LCM, and we can see that this is coming with plus and minus sign here, so this will get cancelled. So finally we get 1 by T2 and N2 as N1 WP in the numerator divided by this one. And if you write this thing for N2, we can write this is N1 WP into T21 all divided by WP T4 plus 1. This is actually for N2 in terms of N1. And since we don't need this equation number 4 anymore, I'm gonna erase even this one and shift this equation, which I might have called as equation number 6. So this equation number 6 I'm gonna write just in the place of equation number 4 and erase all the rest of the stuff on the board just for the sake of space. So this N2 is, this N2 now in terms of N1 is WP T21 divided by WP into T4 plus 1, and here it is simply N1, so which is equation number 6. And I will again use the steady state condition for equation number 3 now. So if you set this dN2 by dt as 0 in this equation, and if you also set, so let me write that dN2 by dt is 0, and also when we take this T42 as infinity again, so that means we don't have any spontaneous emission or non-ready to decay taking place between levels 4 and 2. So if we assume that, then this term also goes to 0, and N3 is there in this and this term, and N2 is there here and here. So we can set the 0 is equals to, if you take N3 as common factor out, WL plus 1 by T32 and N2 here, N3 here, and minus we can write this N2, so N2 into WL plus 1 by T21. So this is what we get. And if you write from here for this N3, then we will be seeing N3. Of course, we can also take LCMs in this as T32 and this T21. So if you do so, then 0 is equals to WL into T32 plus 1 divided by T32, and this is N3 here minus WL T21 plus 1 divided by T21 here and into here. Perhaps I will need to fill my pen, so let me take a quick break here. Hello everybody, I think I did some a bit of filling of the ink in my pen here, but I could not open it for some reason, so I had to do just a trick to actually kind of dip this in the thing, and hoping that it will work, at least for small derivation left for now in this topic. So anyways, here if you actually invert this for N3, then N3 can be written as, of course we can see that this term will remain here, but if we send this towards the left hand side, then we can write WL P21 plus 1 and divided by this is T21, and of course N2 is here. I could call this N2, put this N2 in front, and when we send this guy towards this side, it will be T32 in the numerator and WL into T32 plus 1 in the denominator. And what I can do in the next step is substitute for the value of N2 from equation number 6, so that we can do after erasing the rest of the things. So this N3 now can be written as WL. Of course we can write this T32 by T21 first, and WL to T21 plus 1 divided by WL to T32 plus 1 first, and in the place of N2 I am going to substitute the value of it from equation number 6. So this is WPU here and T21 here, and divided by this is WP T4 plus 1 into N1, and we can notice this T21 which is present in the numerator and denominator will get cancelled here and here, so we may even not write that one as because it's getting cancelled. So now what we do is we may call this as equation number 7, and we need only equations number 6 and 7 now, because they are the ones which will help us in finding out the difference of N3 and N2 in terms of N1. So if we write this N3 minus N2, then from this equation we can write this entire thing in N3 as it is, and so we can write we may even write this term also together. So this N3 will be simply T32 WP multiplying with the first term here, so this is WL T21 plus into WP, then whole thing divided by WL T32 plus 1 and WP T4 plus 1. So this entire thing is of course multiplying to this is N1 here, so this entire thing is our N3 now, and minus we should write N2 from equation number 6. So this is WP into T21 divided by WP into T4 plus 1 to N1. So this is actually the difference of N3 and N2, and we need more space, so let us start erasing all the other thing on the board because we don't need them anymore. So in the right hand side of this equation we can actually take LCM as this product, this term and this term. So if you do so, then N3 minus N2 can be, this will come as it is, T32 T21 also, which is there, WP into WL plus T32 WP. Of course this is actually the first term, and in the next term when we want to write this as LCM, then we should multiply this by this, so minus WL T32 plus 1 multiplying to WP T21. Of course entire thing, this and this will have N1 multiplying and WL T32 plus 1 into WP T4 plus 1 dividing this. So we have this like this, and if we actually multiply this one to each of these terms, we get here T21, T32, WL, WP. So this and this term will get cancelled actually. This and this will get cancelled. So in the numerator what we get is WP into T32 minus T21 into N1 all divided by WL into T32 plus 1 into WP into T4 plus 1. This is what we get for N3 minus N2. And here we can see that if we want to have this N3 minus N2 as more than 0, to have this as positive quantity, we need this guy T32 minus T21 as positive quantity. So this is actually the necessary condition to have population inversion in a 4-level system. We should have this inequality, and if we achieve this inequality in our 4-level systems, then for whatever little pumping power WP, we will easily have population inversion achieved, in which we have N3 minus N2 more than 0, and that will contribute for the stimulated emission of lasing photons between level 3 and 2, and giving rise to amplification and 4-level laser system working. So anyways, this is it. I want to talk in this video, and I will try to meet you next time with some other video, and bye bye for now.